You have two strings. That's the original question exactly appeared in Google onsite. Okay. Usually, if you talk about Google, most of the time it's hard to hit original problem. Even you hit the original problem, it will come with some form of variation or follow-up. Follow-up would be a variation. Okay. So basically, that means you really sometimes for Google's interview, it's really hard about getting the solution. The thought is very important. Unlike Facebook usually it's highly likely you can hit the original problem. All you have to do is basically memorize it pretty good, right? So okay, some student is asking. Not sure. Might be something with your problem, okay? With your computer, I'm really not sure. Maybe student 65, you might try like iPad or iPhone. Maybe that's smoother. Okay, let's continue. Okay, all right. So the question, let's look at the question, okay? So basically, it wants you to return true or false, right? For this question. This is the original problem. The most caveat or trap is this test case. Like here, if B is mapped to A, right? You don't want another letter to map to the same A already appear. So if you have B mapped to A, you cannot have O mapped to A. Okay, so that's one test case you might miss in this problem. Okay, so let's switch to the Collab editor. So let's talk about the first about the solution. I think the version I have right here is the most optimized. If you have better one, please let me know. Okay, but I think the one I have is the most optimized, so I'm gonna talk about it. Okay, so this is basically so first corner case check, right? If one is null, the other has to be null, right? Also, second thing, this is very important on line 79. Both T and S has to have the same length, okay? They have to have the same length. Otherwise, you won't have isomorphic, okay? All right, so line 83. So we are building to map to do what? Because this to map is basically we want to map every letter to. So look at the signature, okay? So here, the key is the character, okay? Value is the index. So when you are working with the interviewer, when you're writing your code, it is very important. Whenever you define a variable, let's say if we define a map, you need to let the interviewer know what this map's key is about, what the value is meaningful, right? It's best that you let the interviewer know, right? It's easier for her or him to understand, right? When you define a map. Also, when you define array, you need to tell the interviewer the ith element is representing what, right? You cannot just expect someone else to know it immediately, right? You need to do a good job of explaining your code, okay? That helps you, okay? Chinese have a saying, right? 理解万岁, right? So this here it works, okay? I'm not sure how to translate it in English, okay? You know, let me know. So this map is for S, right? So this map is for T, right? So basically, here we are mapping. Actually, the value is actually the last appeared index of the key of the character, right? The char, right? So it's last. You're updating it, right? So what we are trying to say here is here. Okay, let's look at the line 87 and 88. So we are doing a linear scan, okay? Linear scan. Those are keywords when you're explaining to your interviewer. Linear scan, okay? When you use those terms when you're describing your coding. It's very helpful, okay? So linear scan actually means ON, right? So you're doing a linear scan. So this is runtime is ON, of course, right? So later we'll talk. What's the actual space? We are using a map, right? So that's the actual space. right? So basically, if we have the length of if both lengths is n, right? So you're actually using actual worst case, you actually have O of 2n, right? You're building the this is the space, right? Building the map, right? Okay, some students raise a question. Okay, that's what I'm gonna explain here. Okay, so let's talk about this here in the code line 95. We have two things. Okay, object dot equals. Okay, so what's object dot equals? Actually, I already pasted here on line 113. Object dot equals. So objects dot equals. If I'm gonna open my Eclipse. Okay, here. Okay, hope you can see it. Okay. What is object dot equals? So what is object? Object is belonging to java.util. Okay, it's in the Java util package. Okay, usually a lot of helpful things are in Java util, like a map, hash map, like list, linked list, right? So usually when you in the interview you can use import java.util.star, right, to include everything, right? So when you include the util.star, objects is already included. And for your advice, you should always use objects dot equals ab rather than a dot equals. If you go to work in the future, you use Java, always use this instead of this. Why? Don't use a dot equals b. Okay, always use object dot equals. Why? Because if a is equal to null, you have a null pointer error. Okay, if you a equals b, right, you have a null pointer error, right? You don't want that to happen, right? In most of the cases, you don't want to see that, right? All right. So back, what is object dot equals, right? Just look at the source code. So here is checking the null, right? So always use that. Okay. Rule of thumb, always use that. Okay. Also, it has also other useful function. Okay. Like what? You can look at it. Objects has a lot of useful function. I think most useful is the hash. Okay, hash function. Let's look at it. What else does it have? Compare, deep equal, equals, right? Deep equal is also very useful. Hash. Okay. The rest probably not that like frequent. Okay. So what is object of hash? So object of hash can like take a number, like an array of objects. This is splat. This dot 3 dot means splat. What does it mean? So what does it mean is you can pass like a comma b comma c, or you can make a make a array, like a new object like this, a b c. Okay, so it's equivalent. Splat is easier when you splat is easier. It's equivalent to array, but it's much easier syntax. You can do it this way, just using a comma. So it's kind of like a syntax sugar. Okay, splat. Let me write it. Splat. This is splat expression. Okay. So the dot here means splat. Okay. It's equivalent to object array. Okay. It's just syntax sugar. And it actually when you write override equals and hash code. Let me try to find where class I have. Maybe I cannot find it. Maybe this one. I'm trying to find. Okay. Let me do a search. Objects dot equal. Okay. Objects dot equals. Not equal actually. Okay, it's fine. Let me see. Okay, here. Let's for example. So when you write hash code, when you override hash code, you can just use object.hash. Okay, so that's better. Okay, so basically, if you use Eclipse to automatically generate it, it will have some like a formula like with a number 13 or something. I forgot. So I usually do it this way. Okay, this is much better. Object.equals. This is a better way to override equals and hash code. Okay, it's much better. Okay, So let's go back. Okay, let's look at here. That's at point. Okay, so what happened if so this is the follow up, okay? Oh, sorry. I forgot. We still need to talk about the put. Okay, sorry, my bad. Okay, I was head over here. So here, what does put mean? Put here. So let's look at line 141. Okay, so this is the put function. Okay, you put a key and a value. It actually returns something. Okay, so this actually returns something. What does it return? Maybe it's better to do it in the Eclipse. I think that may be better. Let's see. Let's see. Let's initialize a map, right? Like a string. String. Okay. Here, and m dot put. Okay. So let's look at the signature here. Okay. So that is actually better. Can I drag it over? Okay, I can drag it over here. Okay, I can make it bigger. So that is much easier. So it returns the previous value associated with key. Or now if there's no mapping for the key. So if the map doesn't contain the key or the key doesn't exist, it returns now, right? What does it mean here? So basically in the code here, basically if SC and TC didn't appear before, they should both return now, right? So let's say like SC if it's the first time, right? It requires the TC also to be the first time, right? But the first time means what? First time actually means now equal now here. Okay, now equal now. But next time, when let's say here, if we walk through our test case, right? Let's use the egg, and how do we walk through the test case? Actually, egg and so actually during the interviewer asked the candidate to walk through test case. So how do you walk through test case? Let's do the exercise. Okay, here, right? So what variable do we need to define here? How many variable? So this is how you walk through test case with the interviewer. So this is the input, okay? Input. So this is the S, right? S is egg. T is add, okay? So what do we have? We have a variable map, right? That is empty, right? We have a variable T map, right? So that right now is empty, right? So that's how you walk through the test case, okay? Here. This empty bracket means the map is empty, okay? So what else do we have? We have SC, right? We have TC, right? That's the variable, right? Also, you have the I, okay? So I right now is pointing to 0, right? SC is E, right? And TC is A, right? So when it do the put here, what we are matching? So what we get is now equal now. So it's true, right? So what we will do, we'll put a 0 and a 0 in the map, right? Oh, actually it's E and a 0 and the A 0 here, right? In the map, right? Key value. Okay, then I become 1, right? So S become G, SC become G and TC become D, right? So here we also get a line 97 now equal now, right? So here also we will update the map to be. It will update the map to be G 1, right? And it's the egg. Okay, so here. Oh, okay. So it's the D1, right? So first they return now. Now we are updating. First it return now, and also it will update the map to be 1, index 1, right? Now the I become 2, right? The SC and TC here right now is still G and D, right? Because the last letter, right? So what do we get here when we do the put is 1 equal 1, right? Because the key is existing in the map, right? It will return it. But remember, we are gonna update to be last appear index of the key, right? So now it will become 2. And D will become 2, okay? So it will become 2. Got it? So that's the code, okay? Anyone have a question here? Anyone have a question? Okay, let's continue. Okay. So now let's talk about the follow-up. Okay. Yeah, let's talk about the follow-up. Okay, I'm a little bit slow behind schedule. Okay, so what's the follow-up? So if we're talking about like isomorphic, we have a bunch of string. What do we do, right? Of course, right now, if you already have this is isomorphic function, what can you do with when here the strings a lot, right? Like a multiple string, right? Okay. So usually this actually, I think you should know that later the interviewer will for certain to ask, what if the string is like already fixed, like here the strings variable is preset, right? Preset. So what it means preset is like it become like an instance variable, right? It's just like a loaded once. What does loaded once mean? Loaded once means you will call this function here, line 75, several times, like a number of times, but the strings are not changed, right, here. So that's usually how it goes, right? So that means, right, what you should do, you can pre-process here the strings one time, no matter how costly it is, because it's only one time, right? Because it's only one time to process the strings here, right? It's one-time cost. You can do it at night, right? Nobody's here. One-time cost. So you can pre-process it, right? And then later you will call this function multiple times, right? So what's the brute force? The brute force is just do this, right? You iterate this here, the strings, right? You iterate the strings, and the question is if any of this is isomorphic, right? You return true, right? Here, if any of the string have isomorphic, you should return true, right? After you are done, you should return false, right? But that's not good enough, right? Every time we have to, if the strings are very big, right? If the strings are very big, that's too costly, right? Very costly. What should we do? If it's too big, we don't want to iterate all the isomorphic string again, right? So, solution number one, okay? Solution number one, what should we do? We should first look at the case. The line 93, right? So you have to have the same length, right? So you can pre-process it to be a map. The key is the length. Okay, key is the string length. Okay, value is the list of string. Okay, so that's number one. So it become a map. So what we can change here is that you only need to do m.get, right? Get. So probably here is probably do it here this way. So m.get here is get t.length, right? You call it the length, and then here is the list of string you actually want, right? So let's call it L here. So iterate through it. But if it's not existing, right? If L equal to now here, doesn't mean you don't have anything, right? Java, the most painful thing with Java is the null pointer. So you always be careful about null, okay? Turn false, okay? Right. So that's the case, right? So that's still not good enough, right? Why? So that is somewhat good, but still we can do better, right? How do we do better? Anyone know? Anyway, for time's sake, let me continue. So isomorphic is transitive. What does transitive mean? What does transitive mean here? So if we look at the here, let's look at here, right? This is a recent Google interview question, like in lead code. Actually, it's very new. Actually, so you see what is transitive here? Transitive. It's kind of the transitive term actually come from mathematics, right? It means like a equal is transitive. Why equal is transitive? Because if we look at here, right? If A equal B, if B equals C, right? We can deduce that A equals C, right? So actually the equal sign is transitive, right? So if we look at the sentence similarity number 2, right? If great and good are similar, and fine and good are similar, then great and fine are similar. So it's transitive, right? What does it mean here? So if Bob and mom are isomorphic, and mom and dad are isomorphic, those words are all isomorphic. They are actually like in one class, right? They are actually like one class because they are all isomorphic, right? So, like a cat and a dog are isomorphic, right? They are all isomorphic, right? And the egg is the same. If egg is isomorphic to egg is isomorphic to food, food, and food isomorphic to fish. They are like in the same. They are the same, right? Doesn't this remind you of something? This is kind of like a union find, right? Union find? Anyone know union find? Union find, it means what? We only need the root. We only need the root, okay? All we need is the root. What does it mean here? This means like if we have the same isomorphic class, we can remove all this word. We only need to keep Bob. All we need to keep is Bob. We can remove all the other. We can remove all the other. We only need to keep the cat if it's isomorphic. We only need to compare it with egg. If you compare with egg, you don't have to compare with egg or foo or fee, right? You only need to compare with the one word in the class. Okay, it's kind of like the root in the union find, right? It's kind of like the root, right? Because they belong to the same union, right? So when you do the pre-process here, you can remove a bunch of words, right? You only have some word left.
Our public site, Xcode Career Service, you can scan the barcode to follow our site. We basically have training and classes every Saturday, 7 p.m. Pacific time. So if you are interested, you can always contact us, or you can join our WeChat group. You can add my WeChat ID. I will add you into our group. So welcome.